Welcome back, and to the final module in this online course. You're almost done. So far, we've looked at the different types of landfilling methods available and focused in on the benefits of semi-aerobic landfills in locations where cost and technological complexity are important considerations. In this final module, we're going to look at the preconditions and what needs to be prepared to establish controlled landfills and some of the common operational aspects required for all controlled landfill types. Before we go into the aspects related to establishing the landfill, we must first acknowledge the critical importance of operations from the very beginning. When landfills fail to perform, it's overwhelmingly due to poor operations. This can include a lack of operational finance, technical skill, equipment, or human resources, to name a few. Landfill design is rarely an issue. Here, we see a good example of inefficiency. This bulldozer should be pushing waste to optimize the space, but as you can see, it's barely moving anything. All it's doing is burning fuel and wearing out equipment. Waste remains exposed to the rain and wind. Ultimately, operating costs will increase. So prior to constructing a new landfill site, it's essential to put in place the conditions that guarantee a competent operator will work the site from the very beginning. Think about who will be the operator. This could be the municipality directly or outsourced to a private company, or a combination involving a public-private partnership. This can be put in place on the existing disposal site. Even if the current site is an uncontrolled open dump site, the skills of an operator can and should be proven by enhancing operations on the existing waste mass prior to starting work on any new or improved site. This requires considering not just who the operator is, but how the client, most often the municipality, will be able to set and enforce control level standards. Identify where the operational revenues will come from. That will enable you to identify who the revenue collector is and who is responsible and accountable for ensuring the operator has the required resources to operate the site to the required standards. We'll go into the details of operations once we look at how to establish a new landfill. Optimizing operations at an existing dump site before transitioning to a new landfill site can significantly enhance long-term sustainable waste management. In many cases, this proactive approach can even eliminate the need for constructing a new site altogether. All too often, the political decision is made to suddenly close a poorly managed dump site and construct a modern sanitary landfill at a new location. However, this approach is often destined to fail. Instead, the priority must be to build the capacity of operators and regulators so they can manage the existing dump site to at least a basic control standard. It's interesting to note that when this training was being developed, we could find no example of successful sanitary landfill establishment without rehabilitating the existing landfill first, and we did look for one. So, in cities where landfills already exist, often as non-sanitary open dump sites, it's highly recommended to prioritize rehabilitation and improvements before considering new landfill construction. By upgrading operations and increasing performance standards, cities can save money, reduce environmental impact, and maintain public trust. Improving an existing site often presents fewer financial and social barriers compared to establishing a new landfill. Developing a new site may spark public opposition due to concerns about the creation of another open dump site. Community members may worry about proximity, pollution, and the risk of repeating past mistakes. And waste pickers who rely on the site for income may fear job loss if operations move to a new, more distant location. A poorly managed transition can increase the risk of illegal dumping, particularly if the new site is inconveniently located or lacks sufficient operational planning. By focusing on upgrading the current landfill, cities also provide valuable on-the-job experience for operators and field workers. These enhanced skills enable them to manage the site more effectively and sustainably, reducing the likelihood of repeating operational issues elsewhere. Rehabilitating an existing dump site isn't just a cost-effective approach, it's a step toward creating a cleaner, more resilient future. With careful planning and community engagement, cities can transform their waste management landscape, benefiting both the environment and their residents. As the saying goes, sustainable waste management starts with smart decisions today. The first step in this process is to ensure that the critical institutional functions for integrated solid waste management are established. These include roles for a clear client function, revenue collection, and operational delivery. The client, often a municipal or local government, is responsible for overseeing and ensuring reliable waste management services that meet required standards. The revenue collector ensures financial sustainability by collecting fees, while the operator delivers the waste management service on the ground. Together, these functions ensure accountability and minimize the risk of waste leakage along the value chain. For the client function to be effective, several key aspects must be addressed. These include clear objectives and service level requirements, financial oversight, effective contract management, regulatory compliance, stakeholder engagement, and performance monitoring. Step 2 involves selecting the right operator for the landfill. This requires a comprehensive understanding of local capabilities, including procurement structures, supply chains, and technical expertise. Cities must carefully compare these local capabilities against the requirements for sustainable landfill operations. Assigning clear roles and responsibilities, ensuring accountability, and engaging with key stakeholders at both the operational and management levels is crucial. Community input must also be considered when selecting an operator, alongside sustainable financing strategies that support cost recovery. Learning from past experiences in municipal service infrastructure can help avoid repeating mistakes. By investing in institutional capacity and making informed decisions, cities can transform their waste management systems. Addressing both operational improvements and community concerns will lead to more effective, sustainable solutions that serve both the environment and the people. Integrated waste management solutions begin with capacity and collaboration. When considering a new sanitary landfill, the site selection process remains similar whether it is aerobic, semi-aerobic, or anaerobic. The main operational difference lies in gas and leachate management systems, but the daily waste placement operations are consistent across all controlled landfill types. For effective site selection, it is crucial to involve experts and engage with potentially affected communities early in the process. There are 16 elements that must be considered during site selection. Distance from the city centre. Locations over 20 kilometres away increase the risk of illegal dumping, necessitating enforcement and the establishment of transfer stations. Site accessibility, such as the presence of access roads. Catchment area status. Relationship with nearby drinking water resources. Land slope conditions. Agreements and relationships with neighbouring communities. availability of construction materials, precipitation levels, site size, including buffer zones and potential for expansion, geographical and geological conditions, soil properties, ground bumpiness, extent of required land excavation, relationship with natural watersheds, presence of nearby communities and buildings, site security to prevent theft or vandalism, particularly for equipment left overnight. By carefully considering these factors and incorporating community feedback, cities can ensure that the selected site meets operational and environmental standards, fostering long-term sustainable waste management. It is critical to highlight that proper landfill site selection requires comprehensive and cross-sectional decision-making. Cooperation among city administration departments and collaboration with academia and other stakeholders is critical to success. Semi-aerobic landfill management can be achieved even without heavy machinery for smaller daily waste loads. However, when daily waste inflows exceed tens of tons, at least one bulldozer and one excavator become essential for proper daily landfill management. Ideally, having one bulldozer and two excavators or two sets of these machines is highly recommended. The client, revenue collector, and operator must estimate and secure the necessary budget for these machine arrangements. Budget is also needed for procuring sufficient field staff and equipment for key infrastructure, such as leachate collection pipes, gas venting systems, and leachate treatment ponds. Without this commitment, even a semi-aerobic controlled site can quickly become an uncontrolled open dump site. It is also crucial to use machines equipped with tracks, as landfills have slippery and unstable surfaces. Machines with standard wheels or tyres are not recommended for site management due to the increased risk of getting stuck, tipping over, and punctures. Planning from the beginning for the long-term maintenance parts, budget, and human resources required for equipment is essential. The working environment of a landfill site is very unique and challenging. Skilled machine operators are essential. Existing staff need to be upskilled, or you'll need to recruit and train the new ones. As the landfill working environment is very harsh, heavy machines must be maintained very carefully every day. And keep in mind that spare parts may not be easily available in some local markets. So we must avoid machine damage as much as possible through careful operation and preventative maintenance rather than just reactive maintenance. The main piece of machinery for daily operations is the bulldozer. It's a key piece of equipment in most landfills due to its ability to level, compact, and cover waste effectively. It's highly suited for waste disposal tasks and cover soil work. The defining characteristics of a bulldozer include its crawler tracks and a front-mounted blade. The blade should ideally be a higher waste handling blade, designed specifically for landfill use, rather than a smaller dirt blade. Bulldozer sizes are classified by body weight, with models ranging from 4 tons to over 100 tons, depending on the operational requirements and daily waste loads. They must be procured in the appropriate size and number according to the daily incoming waste as per the table shown here. For daily waste amounts exceeding 200 tons, multiple bulldozers are required to maintain efficiency. Over time, continuous operation of heavy machinery can lead to breakdowns and the need to replace expendable parts. The excavator is a versatile piece of machinery essential for digging up waste and other materials, forming bunds and slopes, loading trucks, and transporting materials over short distances. Excavators are typically mounted on crawler tracks, allowing them to operate effectively on weak and unstable ground. The water truck plays an important role in site management, where water resources are available by controlling dust levels and providing water for sanitation purposes, such as hand washing stations and shower areas for workers. Wherever possible, even when not in active use, the truck should be kept filled with water to assist with initial firefighting should the need arise. A water truck on standby can be a critical tool for quick response in preventing fire from spreading. It's essential in all waste management operations, but particularly landfill operations, that specific entities and persons are assigned to conduct all tasks and responsibilities, so they can be held accountable for delivering the required standard of implementation. It is therefore important to make clear the institutional structure of the landfill management. In other words, who will take what actions for each specific aspect of daily landfill management. Within this context, and as introduced at the beginning of this module, to ensure sustainable landfill management, the client, often the city or municipality, must secure funds, machinery, staff and materials. At least one bulldozer and 1 or 2 excavators must always be available on site, regardless of whether the landfill is aerobic, semi-aerobic or anaerobic. The client must estimate annual costs for machinery, staffing and maintenance, while also preparing for post-closure requirements. Semi-aerobic landfills require maintenance for 20 to 30 years, and anaerobic landfills may need even longer. Field staff must be present 24 hours a day to monitor and record incoming waste, mitigate illegal dumping and burning, and track waste collection vehicles. Their role ensures operational accountability and safety. The management entity must also procure materials for vertical extensions of gas venting systems and monitoring equipment for leachate and gas levels. Estimating the full requirements for landfill management tailored to the city's needs is vital. A strong and ongoing commitment to securing funds, machines, staff, and infrastructure is essential. Controlled landfill operations should only begin when all these resources are secured, ensuring a solid foundation for sustainable waste management. The risk, if this is not secured, is that equipment rapidly falls into disrepair due to the simplest mechanical breakdown, and the landfill site quickly becomes an uncontrolled dump site that cannot be recovered to a controlled landfill level. Controlled landfilling can stabilize a dump site, but it cannot reduce the overall amount of waste arriving at landfills. To address this, the efforts to promote the 3 R's, reduce, reuse, and recycle, must be implemented. Involving the business sector is critical for making reuse and recycling activities sustainable. Programs should be designed around what types of sorted valuable waste are marketable to local reuse and recycling businesses. An efficient waste collection system is also essential for local governments managing solid waste. When collection services are optimized, saved funds can be redirected to support landfill rehabilitation and improve long-term operations. Conducting a time and motion study, TMS, is an effective way to analyze the current waste collection system and identify ways to improve collection routes, methods, and vehicle use, ultimately enhancing efficiency and reducing costs. Clean, uninhibited access to the landfill by all types of vehicles that might transport waste to the site, including everything from hand carts to semi-articulated trucks, is essential. For this, well-constructed and maintained all-weather access and on-site roads are required, which includes appropriate continuous operational budgeting and technical implementation. Access roads need to be constructed to have a structure higher than the rain and leachate running ground as illustrated in this diagram. This will prevent the road from becoming submerged in water by rains and allow waste collection vehicles to easily travel even during rainy season. It is recommended to build the access road by banking old waste, which was landfilled 3 or more years ago. The reason for using old waste is that it will, to some degree, have decomposed to soil, is relatively easy to spread and compact, and is more suitable for road construction compared to newer waste. After raising the road 50 centimetres or so using old waste, compact it thoroughly with heavy machinery. Vehicle tyre punctures can be avoided by spreading crusher-run stone or stone-mixed soil to a 20 centimetre thickness to finish the road surface. Rainwater can be removed more swiftly by giving a cross slope to the road and digging unlined side ditches on both sides of the road. Also, to reiterate early guidance, embankments can be essential as a landfill structure that make it possible for the landfill to optimise available airspace. When building embankments, the site's bulldozer and excavator can be utilised. Remember that an overall slope gradient of around 1 to 2 must be achieved by giving each slope a gradient of 1 to 1.5 and building 3 metre high steps at 3 to 5 metre intervals. This will allow more waste to be piled up while forming more stable slopes with good compaction. It will result in a greater landfillable amount for the entire landfill site. Proper daily management of a landfill is very important. Without this management, any controlled site would go back to a non-sanitary open dump site very easily. The most important element of landfill operation is how to receive daily waste. This illustration explains how bulldozers should work when receiving daily waste. Bulldozers conduct waste compaction by their own weight and by pushing waste. The machine should go back and forth at least 5 times on the same area to compress waste sufficiently. And compacted waste must be arranged so that waste sloped layers are accumulated. The thickness of each layer must be around 3 meters. There are 2 ways to compact waste, namely the push-down method or the push-up method, as shown. Spread about 50 centimeters of waste on the slope that has a gradient of 1 to 2 or 3. Once the landfill ground is fully covered with this compacted waste with a height of 3 meters, a new 3 meter waste layer must be added on top of the first layer. Please keep in mind that gas venting systems need to be extended vertically upward. Without proper site instruction, there is often a risk of collisions between waste pickers and waste collection vehicles, or between waste pickers and site-heavy machines, such as bulldozers and excavators. We receive many reports about critical injuries or even deaths of site workers due to these types of collisions. Yet they are easily avoided. Staff in charge of landfill management must make efforts to avoid these fatal collisions as much as possible. One recommendation is to separate machine works and waste pickers' work. For example, one day waste pickers can collect valuable waste at section B when new daily waste is dumped there. At the same time, in section A, heavy machines like bulldozers and excavators can work to spread waste and conduct necessary waste compaction. On the next day, heavy machinery can work at section B for waste spreading and compaction, while waste pickers can collect valuables from newly dumped waste at section C. If waste pickers can wait for 1 day for waste collection vehicles to unload daily waste completely, you can avoid a collision risk between waste collection vehicles and waste pickers. But do keep in mind that this arrangement can be difficult to implement. Waste pickers tend to want to collect valuables from waste collection vehicles as soon as it arrives. So some discussion with them will be necessary to arrive at a solution that suits all. Fires require oxygen, fuel, and heat to burn. Landfills contain a lot of fuel, such as plastics, wood, and other combustible materials, sparks from electrical equipment, waste pickers burning plastic insulation from electrical cables, machinery operations, and hot ashes in fresh waste can all ignite fires. In anaerobic conditions, landfill waste can generate gases such as methane. When fires start in such landfills, they can result in explosive events, suspend operations, and release harmful smoke into nearby areas. Immediate action is therefore critical when a fire starts. Fire extinguishers should be strategically placed on operational equipment for quick access. Surface fires can be relatively straightforward to extinguish using water or push cover soil. In deep fires, shutting down the methane supply is essential. Methane buildup can fuel and spread fires, making the situation more dangerous. Care must be taken as methane concentrations between 5% and 15% in the air can lead to explosions if mishandled. Effective firefighting involves digging unlined ditches around the fire and filling them with water to prevent spread. When digging, caution is needed to avoid introducing excess air that could intensify the fire. Additionally, gas venting systems should be installed every 20 to 30 meters around the affected area to lower methane concentrations. Cover soil should be applied, starting from the perimeter toward the center of the fire. The soil layer should be at least 20 centimeters thick. If soil is unavailable, old composted waste can be used as an alternative. Once the fire is out, gas venting systems should be installed to ensure continued safety. If fires spread across a wide area, the site should be divided into sections of 20 to 30 meters and the same methods applied. After confirming that fires in each section have been extinguished, the scope of vertical gas venting system installation can be expanded to further reduce risks. Fires forming and continuously burning in uncontrolled side slopes of landfills are common due to the wind entering fissures in the slope and feeding the fire oxygen. This highlights the requirement for strong earth-covered embankment slopes around the perimeter of the site that are continuously maintained and raised with the waist height to create a protective barrier to slope destabilization and fire establishment. It's now time to start thinking about how you can begin to put the lessons learned to use in your city. So discuss with your colleagues whether the introduction of controlled landfilling is needed and possible in your city. And if it is, start estimating how much the city needs for sustainable operation of their landfill and how the city can secure the funds, staff, machines and materials. Make clear which controlled landfilling method your city can introduce, the anaerobic method or the semi-aerobic method. And remember to check and apply your local context and point out reasons why the selected method is the most suitable in your city. And finally, if you do start to look at introducing controlled landfilling methods in this online course, especially the semi-aerobic landfilling method, the ACCP Secretariat will be pleased to provide assistance in helping you move forward. You can see their contact information here, or you can follow the links you'll find below.
And that's it. We're done. Thank you so much for watching and completing this online course. We hope it's been of use and we wish you the very best of luck in implementing the steps necessary to improve municipal solid waste management in your city.
Goodbye.
Goodbye.